This video is for 7.3 talking about histograms. And in this we've got to evaluate and actually create a couple histograms. In this one we've got a list of numbers and we're asked to create a histogram with 6 intervals beginning with 15 to 28. So that means I'm going to have 6 columns. So there's 1, 2, 3, 4, 5, and 6. And I'll erase that little extra piece right on the end there. Now we have 6 columns. And the first one is going to be 15 to 28. Next one is going to be 29 to whatever. Now, how far did we go to get from 15 to 29? That was, we added 14. You just find the difference. 29 minus 15 is 14. So what's 29 plus 14? That would be 43. And what's 43 plus 14? 57, 71, and 85. So all I did was added 14 to each one of these. And we do the same thing here. Add 14, we get 42, 56, 70, 84, and 98. Okay, and you see it's also the number right before the last one. But by knowing that we're adding 14 to each one, we know where the last one goes. So now we have our columns, our intervals. We're going to create just little tick marks over here. And I'm not sure what those numbers are going to be yet. Let's first find out how many of each of these we're going to have. So from 15 to 28, how many do we have? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 here. And I'm just going to make that note there. Now the next one, 29 to 42. That's 1, 2, 3, 4, 5, 6, 7, 8. And this would be helpful to put these in order from smallest to biggest. Then you wouldn't have to go through this. You just go up the list. Okay, the next one is 43 to 56. There's 1, 2, 3, 4, 5. Now 57 to 70, I've only got one left here, and that's 95 and 68. Sorry, 2 left. So there's 1 here and 1 at 95. And that's all the numbers. So the highest I need to be is at 11. So 1, 2, 3, 4, 5, 6, 7, 8. That's not going to be enough. So I'm going to go 2, 4, 6, 8, 10, 12, 14. Now 11 is going to be right here. 8 is going to be right here. 5 is right around here. 1 is way down here. 0 and 1. Okay, so there's my histogram. And just to clarify, clear it up, I'm going to erase these extra marks here, just so we can see it a little bit better. And you don't have to do that. I'm just doing it to make it easier to see. so that I can explain the rest of it, but you don't need to do that if you don't want to. Okay, so there's my histogram. Now I would recommend that you number it just like that, so that there's no mistaking what the numbers are. Which measure of center and variation best represents the data? Well, the best measure of center would equal median. Why would I use median? Well, because here it's skewed. Okay, we see all the data on the left side and a big tail on the right side. So that tells me that it is skewed. Okay. Now what variation best represents the data? Okay, what this is asking for is it better for me to use a histogram or a box plot? If I'm using the median, then I want a box plot. If I'm using the mean, then I would use a histogram. Alright, so that's how you do B. A weather station lists the top 20 snowiest major cities. The city in the 20th place has 51 inches. How would you interpret that? Now, sorry, that's off the screen. That's letter C. The reason why I didn't move it up is because we need to be able to see this. So it's got 20th place, it's got 51 inches. Okay, that means it's normally right here, about 51 inches. Okay, somewhere in this, in this bar. Okay, so what does that tell me? If this is the 20th place, okay, 20th place, then that means all the cities on this list, most of them aren't going to be on that 20th place. Okay, or on that list, because that's right up here, and there's only a couple cities higher than that. So how would I interpret that data? I would say that this display, this histogram, does not represent the snowiest cities, or the cities with the most precipitation. That's how I would interpret. So my answer for C would be most cities were not on the snowiest city list. Okay. Now, number 2. The double histogram shows the distribution of a monthly precipitation for 2 towns over a 50-month period. Compare the distributions using their shapes and appropriate measures of center and variation. Okay, so we've got city A there. It appears to be skewed right, meaning there's a tail that goes off. And this one is more centered and more symmetric. Okay, so that tells me that on average, don't forget to write that word, on average, if I can figure out how to spell it, on average, blah, 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 blah. So what do we see? On average, city B, so the average, the mean, the center, is higher on city B than it is for city A. That tells me that on average, city B has greater monthly precipitation. And it also tells me that the precipitation varies more. It's different for city A. It's spread out more. But that's what my answer would be. On average, city B receives more precipitation. Okay? And that's all you have to do for 2, is just tell me on average what's happening. What do you notice? Now, don't forget the part where you explain why. Why? Because city A is skewed right and not centered. Okay, so that's 2. Number 3, The table shows the results of a survey that asked high school students how many hours a week they listen to music. Okay? Make a double box and whisker plot that represents the data. Describe the shape of each distribution. Okay, we don't need a calculator for this because we have all the information right here to make a box and whisker plot. Okay, so my first box and whisker plot is going to have a dot right here at 16. Okay, and then one at 24. Another one at 28, and I'm going to try to make this as accurate as possible. 24 and 28 are much closer than 16 and 24. And 32 is about the same distance away as those. Those are all 4 each. And I'm just getting them from right here. Okay? 16, 24, 28, 32, and now we're at 40. And that's a little more than 4 away. That's 8 away, so I'm going to put that out here somewhere. Now we just connect the lines, make our box, and draw a vertical line. Okay. Now keeping in mind we're trying to compare these two, we want to have the rest of these ones about at the same numbers. So this first one, 18, it's going to be a little bit inside of 16. Okay. Remember, 18. We're trying to use the same number line. So then my next one is 30. Well, 30 is going to be right in here between 28 and 32. And then 38 is going to be right before 40. I didn't label that one at all. 40. So this is 30 and 40. And again, I'm getting them from right here. It's not 40. 38. There we go. I was thinking of that one up there. So 38, and my third quartile is 46. So that's kind of way out here a little bit. 46, and my maximum is 52. So there's my lines, and here's my box. And here's my median. Okay, so now we can kind of see how they're spread out. We've done this, we've drawn them. Now what do we know? Well, we see that this one, the distribution for the females appears to be symmetric. It's kind of balanced. So we're going to say that one's symmetric. And if we see here 18 to 30, this one's quite a bit more apart than this one. And we can even do the math if we need to, but we see that one is skewed left. Okay. B, compare the number of hours of music listened to by females to the number of hours listened to by males. Okay. The number of hours, what's going on? We see that on average, the median, kind of the middle number. So we're going to say on average, what happens on average? Well, this is the females, this is the males. What happens on average? On average, the males tend to listen to more music than females. How do we know? The males is skewed left and not centered, while the females is symmetric. Okay? So that's what I would put. On average, males tend to listen to more music because it is skewed left and not centered. About how many females surveyed would you expect to listen to music between 22 and 34 hours per week? Okay, now this is where we would say, okay, what's our standard deviation? 6. How do I know I can use it? Because it's symmetric. What's our mean? 28. So if we have 28, We go 1 standard deviation to the right. We would add 6 to that, and that would be 34. 1 standard deviation to the left, that would be 22. Okay, and we've learned that 1 standard deviation from the mean is 68%. Well, what is 68% of 50? 68% of 50 is 34. Okay, so that would be the answer for number C. D, if surveyed 100 more females, about how many would you expect to listen to music between 16 and 40 hours? 16 and 40 hours, again, let's take the mean, 28. Only this time, let's go 2 standard deviations. And what would 28 plus 12 be? 28 plus 12 would be 40. And let's go 2 standard deviations this way. 28 minus 12 would be 16. So here's our 16 to 40. 2 standard deviations is 95%. 95%. So how many is 95%? Well, 95% of 100, remember we're asking 100, 95% is 95. Okay, and that's what it's asking you to do on that one, is those last two, C and D, use the standard deviation to answer those questions. That's how you do number 7.3. Hopefully it helps.